By the end of this lesson, you'll be able to find the equation of a straight line. You'll also be able to determine and use the s and y intercept of a straight line. We know that given a straight line that passes through the points s1, y1 and s2, y2, the gradient is change in y divided change in s. When we cross multiply, the equation becomes this way. Now, let us use the coordinate s, y to replace the coordinate s2, y2. Then the equation will now be written as this. This y minus y1 equals m multiply s minus s1 is what we are referring to as the equation of a straight line. Now this equation of a straight line can be written in the form as plus by plus k equals 0. Let's solve the first question. Find the equation of a straight line joining the point T and V. First of all, find the gradient of the straight line. Gradient is given as change in y, y2 minus y1 divide s2 minus s1. That gives minus 2. Now, we know that the equation of a straight line is given as this: y minus y1 equals gradient m multiply s minus s2. So that gives y plus 8 equals minus 2s plus 28. Now we are saying that the equation of a straight line can be written in the form as plus by. That's the term containing s should be written first. So when we add minus 2s to both sides, we get 2s now plus y. Subtract 28 from both sides, we get 0, which in turn gives 2s plus y minus 20 equals 0. So this is the equation of the straight line mentioned in the question. We have mentioned that the general equation of a straight line is this one, and it can also be written in the form as plus by plus k. Another way the equation of a straight line can be written is y equals ms plus c, where c is the y-intercept, the points where the straight line meets the y-axis. So we have this illustrated in the diagram. In the diagram, we see that the straight line cuts the y-axis at the point C. So it tells us that the coordinates of this point of intersection is going to be 0, c. Let's solve the next question. The slope of the straight line that passes through the point V is minus 2. Find the equation of the line. Okay, we know the equation of the line is y minus y1 equals gradient minus 2 multiply s minus s1. Thus, when you substitute the point V and the gradient minus 2 into this formula, you get what I've just written. So now, we now get y minus 10 equals minus 2s plus 10. Now we can add 10 to both sides and we get y equals minus 2s plus 20. So in the previous question, I wrote the final answer in this form: as plus by plus k equals 0. What we are saying again is that the equation of a straight line can also be written in this form. So in this second example, I've written my answer in the form y equals ms plus c. M is the gradient. So as you can see, my working tells that the gradient is minus 2 as mentioned in the question. Then also the second question says that we should find the coordinates of the y-intercept. The y-intercept is the value c where the straight line cuts the y-axis. We see clearly from question I that the value of c is 20. And so the coordinate of the y-intercept is going to be 0, c, 0, 20 is the coordinate of the y-intercept. Find the equation of the line with gradient minus 2 out of 3 and passing through the y-intercept. Equation has given us gradient as minus 2 divided 3 and y-intercept at 4. In previous example, we saw that at the y-intercept, the s-coordinate is 0. Now, we know that y minus y1 equals m multiply s minus s1 is the general equation of a straight line. Now we have that y1 equals 4, gradient minus 2 divided 3, s1 is 0. Now the right hand side simplifies to minus 2 third s plus 0. Now write the final answer in the form y equals ms plus c. You have your answer this way. When you add 4 to both sides, this is what you get. Now this very question, we can solve it in a second way. Instead of making use of this general equation y minus y1 equals m equals s minus s1, you can also make use of the general equation y equals ms plus c. Equation says that y-intercept is 4. Gradient is minus 2 out of 3. So just substitute y equals gradient minus 2 divided 3s. We learned that y-intercept is c. So in place of c, I put plus 4. As you can see, the answer gotten in method 2 is the same as the answer gotten in method 1. So any of these two methods will yield the same results. Now, we have talked about the y-intercept. How that at the y-intercept, the s-coordinate is 0. What of the s-intercept? What is the coordinate of the s-intercept in the diagram here? Is going to be w, 0. So we should know that at the s-intercept, the y-coordinate is 0, and at the y-intercept, the s-coordinate is 0. Now let's have a next problem here. Find the equation of the line with gradient 4 out of 3 and passing through the s-intercept at 4. At the s-intercept, the y-coordinate is 0. Now, either you make use of the general equation y minus y1 equals m multiply s minus s1, or you make use of y equals ms plus c. Now, we have here that the y value is 0. So put y to 0. Gradient is 4/3. We have that the s value is -6. So our equation is now written this way. Now solve this to get a value of c. We get 0 equals -8 plus c. Add 8 to both sides, we are getting the value of c to be 8. It tells us that this general equation can be rewritten as y equals ms plus c. Now c got in as 8. So this is the equation of the straight line mentioned in the question. Now I have here a straight line and there is a coordinate s1, y1 on the straight line. What we have just seen in the previous example is that when a point lies on a straight line, you can substitute the coordinates of that point into the equation of the straight line. The s1 is the s1 here in the equation of the straight line. The y1 is the y1 here in the equation of the straight line. Once the point lies on the straight line, you can substitute the coordinates of that point into the equation of the straight line. Let's solve the next example. The equation of a straight line is, for this line, determine the y-intercept. We've learned that at the y-intercept, the value of s equals 0. Now, since the y-intercept lies on the straight line given the equation, we can substitute the s coordinate equals 0 into the equation of the straight line. So 6s, now 6 multiplied 0, minus 4y equals 18. So we get minus 4y equals 18. When we divide both sides by -4, what do we get? We get -9 divided 2, or -4.5. So it tells us that the coordinates, we are to find the y value. The y-intercept is c equals -4.5. Now the next question, it says that we should find a coordinate of the s-intercept. And the s-intercept, the value of y equals 0. So we substitute y equals 0 into the equation we have been given. So we have 6s minus 4 multiply y, which is now 0, equals 18. 6s equals 18. Divide both sides by 6. We are getting the value of s to be 3. Now we have to find the coordinates of these s-intercepts. So it tells us that the coordinate is s comma y. That's s equals 3, y equals 0. This is the point where the straight line cuts the s-axis. Now, the third one says that we should find the gradient of the straight line. What we can do is to rewrite the general equation, rewrite the equation of the straight line in the form y equals ms plus c. Let us subtract 6s from both sides, and we now have our working this way. When we subtract 6s from both sides, we have our working this way. Now divide each term by -4 so that y is made the subject of the equation. This now gives y equals 2/3s minus 9/2. So now that we have this equation written in the general form y equals ms plus c, we see clearly that the gradient m is equal to 3/2. So we are done solving the question I. But then note that a person can decide to use this method to solve the question number I, because in this solving we see that the value of c, the y-intercept, is equal to -9 divided 2, which is same as -4.5. Remember when we solve question I, this was the very answer we had. So this is a second method you can use to solve. Now, the next question. B is the point of the line segment. B is the midpoint of the line segment QR. Okay. We have a certain line segment QR and B is the midpoint. Okay. This straight line QR is inclined to an angle of 45 degrees with the x-axis. That's the horizontal. Find the equation of line QR. Okay, we know that general equation is y equals ms plus c. But then we need the gradient of this straight line, m. How do we determine m? We can use the formula m equals tan theta. Tan the angle to which the straight line is inclined to the horizontal or the x-axis. Tan 45 degrees gives us 1. Then, so it means in place of the m in the general equation we can put 1. Then again, we have a coordinate 2,1 on the straight line that we are finding. So we can substitute this point into the equation on the straight line. So this equation becomes y, which is now 1. When you go to the coordinate b 2,1, the y value is 1. Gradient, we have gotten 1. The x coordinate of the point b is 2. So we now get, subtract 2 from both sides, you are going to get -1 equals c. It tells us that the general equation y equals ms plus c can now be written as y equals ms plus c, which is y equals s minus 1. We are done solving question A, the equation of the line QR. Now B, the coordinate of r is -4, r. Find the value of r. Now the point r lies on this very line that we have solved. And so we can substitute this coordinate into the equation of this line. The coordinates r, in the coordinate r, the x coordinate is -4. The y coordinate is r. Solving for r, we get minus 5. It tells us that the coordinate of the point R is minus 4, minus 5. We have seen that the equation of a straight line is giving us y minus y1 equals m multiply s minus s1, which can be written in the form as plus by plus k equals 0. Not only can the equation of a straight line be written in this first form, it can also be written in the form y equals ms plus c, where c is the point where the straight line meets the y-axis. And these key points we should note are the s-intercept, the y-coordinate is 0, and the y-intercept, the s-coordinate is 0. And that's what we are indicating in the diagram here. Then also we should note that whenever a point lies on a straight line, we can substitute that point into the equation on the straight line. See you in the next lesson.